The water circulation system in the Atlantic is losing stability. The Gulf Stream may collapse in 2 years. Recent research suggests that the system of ocean currents that regulates the climate in the Northern Hemisphere may soon become destabilized. Scientists have calculated that this system will collapse, with 95% certainty, between 2025 and 2095. This could mean permanent changes to Europe's climate. The stability of a key element regulating the climate in the place where we live is seriously threatened. Scientists are not so much wondering whether we will be threatened by climate chaos on this account, but when will it happen? And the latest research is not optimistic. Scientists at the University of Copenhagen have determined that human-caused climate change is destabilizing an important system of ocean currents that helps regulate the climate in the northern hemisphere, including Europe. This system is on the verge of total collapse, and according to researchers, it will happen sooner rather than later. Calculations indicate that this may happen in as little as 2 years. The results and description of the research were published in the journal Nature Communications. The constantly moving subsurface water circulation system is called the Global Transmission Belt, or, more technically, the thermohaline circulation. Its Atlantic part is called the Atlantic Meridional Overturning Circulation, AMOC, and it includes the Gulf Stream, which sends warm and salty water from the equatorial regions to the North Atlantic, where heat is released into the atmosphere, which in turn, it warms Western Europe. Then the waters around Labrador and Greenland cool and become denser before sinking to great depths and returning south. AMOC is critical to climate stability in North America as well as Europe. Circulation has been under scrutiny for years, because any disruption to it would have serious consequences for us. The AMOC is responsible for relatively mild temperatures in Europe and influences weather systems around the world. The possible collapse of this system, with the current level of global warming, may have serious consequences for the weather and climate in the world, especially in Europe. Both the Gulf Stream and the entire AMOC are of key importance not only for climate stability, but also for marine life. Along with the circulation of subsurface waters, oxygen and nutrients are also transported. Generally, AMOC is able to function in 2 modes. The first one is faster, stronger, and that's what we're dealing with now. The second one, slower and weaker, would be problematic for us. So far, it has been estimated that the transition from the first to the second mode could happen in the 22nd century. However, the impact of anthropogenic global warming should be added here, which may accelerate this process. and unfortunately significantly. But what can disturb this flow of water, and how is it related to global warming? Well, melting ice caps become a source of excessive amounts of fresh, thinner water, which ends up in the AMOC in an unfortunate place, in the north, near Greenland. As a result, the flow of water begins to gradually slow down. The AMOC is already at its weakest in about 1,000 years. The last time the modes changed was at the end of the last glacial period, which was associated with a warming of the climate near Greenland from 10 to 15 degrees Celsius. And it happened in just a decade. If, however, this switch were to be activated again, we would have to reckon with a temperature drop of 5 degrees Celsius in a similarly short time. Data on the strength of the AMOC has only been directly collected since 2004. So, to make a more accurate assessment of how it is changing, scientists had to use water temperature data dating back to 1870. Particularly in the area near Greenland's subpolar vortex, this is where the water coming from the south begins to subside. The information collected in this way was entered into the statistical model in order to assess the changes taking place in the context of AMOC functioning. The results shocked even the researchers, because it turned out that the circulation collapse window may open as early as 2025, and it will only open wider with each subsequent one. It remains to be hoped that those who are skeptical about these analyses are right. Some experts have noted that there are several unknowns and assumptions that need to be explored. First of all, it is unclear whether the observed evolution of the AMOC surface temperature can be related to the strength of its circulation. Rock, astrophysicist. Queen's Brian May releases a map of the asteroid. Sir Brian May is an extraordinary character in many ways. He is the guitarist and co-founder of the group Queen. He created such hits as We Will Rock You, Who Wants to Live Forever, Too Much Love Will Kill You, and The Show Must Go On. Few know, however, that May also has a doctorate in astronomy, and his 3D map of the Bennu asteroid will soon be released. In 2020, the object was explored by the OSIRIS REx probe. With this data, May and astronomer Dante Lauretta of the University of Arizona created the world's first complete 3D asteroid atlas. After 7 years of space travel, exactly on September 24 this year, the OSIRIS REx probe is due to return to Earth. The device developed by NASA will bring with it rock and dust samples taken from the surface of Bennu. Scientists hope that thanks to them they will better understand the process of planet formation in the solar system. According to experts, There is a high probability that the asteroid will hit the Earth at the end of the 22nd century. This is one of the reasons why the OSIRIS-REx mission is so important. Learning about the construction of the facility is to help develop a mission that can save humanity. The new book features 3D images of Bennu. The authors also reflect on the beginnings of life on our globe. In the introduction to the publication, Loretta describes her first meeting with May in 2016. We briefly corresponded about the OSIRIS-REx mission and my hometown of Tucson, Arizona. The artist spent some time there, admiring the beauty of the Sonoran Desert, recalls the scientist. I was a huge fan of Brian's music. The fact that I corresponded with one of my childhood heroes was amazing. May turned out to be a true enthusiast of space research, writes Loretta. Thanks to the images taken by the probe, the scientists determined a safe place to land the device and collect samples. The OSIRIS-REx mission allowed us to get to know the asteroid up close. It was successful thanks to the enormous effort of a team of the best experts and engineers in the world. Now our goal is to present this unusual object in an accessible form, so that it can also be seen and admired by people who are not scientists, emphasizes May. The book includes 3D images and an accurate map of the asteroid. Photos and visualizations are also to be published on the Internet. Few people realize that before Queen was formed in 1970, May, Freddie Mercury and Roger Taylor studied physics at Imperial College London. Bennu is a small object that orbits near our planet. The OSIRIS-REx mission, origins, spectral interpretation, resource identification, security, regolith explorer, aims to study the asteroid and transport samples from its surface to Earth. The probe was launched in 2016 and is due to return soon with samples that weigh about 60 grams. Similar asteroids can provide invaluable information about the formation of the solar system. Scientists want to know the chemical composition of the asteroid and thus better understand how planets and stars are formed. OSIRIS-REx is also a great test for tools that have been developed to collect samples from the surfaces of various objects in space, including Mars. Everything indicates that the mission will be successful.